discussed earlier, right? In application layer, the flow will be data. In presentation layer, data. In session layer, data. But in transport layer, it would be in a segment. Network layer, frames, so on, right? Let's see. Session layer allows two applications on different computer to establish, use and end a session. File transfer, remote login, establishing dialog control, regulates which side transmits, plus when and how long it transmit, performs token management and synchronization. Performs token management and the responsibility of session layer. The responsibility of session layer, it has to maintain the session. It has to maintain the session. It has to maintain the session till the data is transferred. Till the data is transferred, like file transfer, remote login, right? Session is nothing but end to end, end to end. What I mean to say is, if I log into one application or if I log into some Gmail account, say, we are very familiar with that, right? So I'll take the example of Gmail account. If you log into Gmail account, then session will start. When I log out for Gmail account, the session will end. Okay, the period between login and logout, the whatever it will do, that is a session. Okay, the session layer is responsible to maintain that session and performs token management. In the session, you may pass lot of information, or you may pass lot of requests. You may do lot of transmissions. It can be file transfer or remote login. So the responsibility of session layer has to maintain that one. Okay, has to maintain those all the activities which is performed in a session layer, which is performed in that particular period. Right. So it will take the data, it will maintain the session, the data is alive, and it will do token synchronization. It will do token management. Okay, so it will collect the entire data and it will do token management, right? Transport layer manages transmission packets. Okay, manage transmission packets. Repackages along messages when necessary into small packets from transmission. Reassemble packets in a correct order to get the original message. Handles error recognition and recovery. Transport layer receives, acknowledges packets, deliver, resend missing packets. The very important layer is transport layer. So this is a layer which is connectivity between software and hardware. This is a layer which is connectivity in between software and hardware. We can say this is the heart of that OSI model. Like for example, in a human body, heart plays a very major role, right? The responsibility of heart is it has to supply the blood to various parts of the body. Similarly, the transport layer plays major role in this. It will collect the data and it will convert into packets. What it will do? It will divide the data into segments. Okay, it will get the data and divide the data into segments. At the receiver's end, it will collect those segments. It will collect those segments and reassemble. Okay, and so what happens is, if a system A sends the data to system B, system A sends the data to system B, what happens is the transport layer, in the transport layer, say suppose if I send, hi, how are you? From system A I will send, hi, how are you? Then in a transport layer, it will divide, hi, one packet, one segment, how one segment or one packet, R is one packet, one segment, and it will pass. Okay, so it will divide. and it will transfer those packets to the packets or segment to the destination device or destination machine. In the destination machine, what this transport layer will do, it will rearrange the packets again. It will rearrange the segment. It will combine those segments in a sequential order. Reassemble sequence in a sequential order. Okay. So finally, the receiver side, whatever message I send, that will be there. Right. Same, hi, how are you? Right. Apart from that, what it will do? Handle the error recognition. It will handle the error recognition. In a form of dividing the message into segments and passing, there might be a situation where there might be missing some packets or segments, right? So it will identify. So it will identify those missing thing. Again, it will recover those one. Again, it will recover that one. So handles the error recognition recovery. It will identify the error. So data will transfer from data to segments or packets. Okay. So that is about the transport layer. So that's why it's called as an heart of the OSM model or OSI7 layers. Okay. Network layer manages addressing routing of data into subnet. Addresses message and translate logical address and names into physical address. Determines the route from the source to the destination computer. Manages a traffic problem such as switching, routing, controlling the conjunction of data packets. Route can be based on static table determined at start of each session, individually determined for each packet, reflecting the current network load. So manages the address and routing of the data in the subset. So what this network layer, it will manages the address and routing. The information comes to network layer, the packets comes to network layer. Now the job is the network layer to address those to which destination that particular information or the particular data to be transferred. In a network there might be multiple systems. Okay, to which system the message has to be delivered. Those routing management will be done in network layer. Okay, those routing management will be done in network layer. If I send a message, say suppose I am sending a message from system A to some system C. So how this will, in a network there might be A, B, C, D, X, Y, Z, lot of systems. Maybe say suppose there are 15 systems in a network. To which system the message has to pass is decided or maintained in the network layer. Okay. So this is the layer which will do addressing, which will do manages addressing and routing part. Determines the route from the source to destination of the computer. It will determine from which source the information came in and to which place the information has to be delivered. Manages the traffic problems. Mean is the network might be very busy. This experience you may observe when you call someone. If the message there would be some there would be some response. Currently this network is very busy, right? Currently this network is very busy. So nothing but there are a lot of requests going in that network. There are a lot of requests going in that network. Okay. So that would be managed by network layer. Those kind of issues or those kind of situation, if those kind of situation arises, or that will manage by then in a network layer. How it will manage? Based on the priority. They'll say the network layer will set a priority to the data. Which is the higher priority, it will send the data first. It can be based on a static table or determined as a start of each session. Okay. It can be static table or determined as start of each session. So here network layer plays a major role. Network layer manages the address and routing of the data within the subnet, and it also determines the source and destination. It also determines the source and destination. It manages the network traffic, switching, routing and controlling. It manages the network traffic. Right? When I say network traffic, if the network is very busy, unable to send the information, then network layer has to manage that one. How it manages? Based on the priority, based on the session. There might be a lot of factors. It might be based on session, it might be based on the priority, or it might be based on the static table. Okay. There might be some fixed things, which one to go first or how to manage the things. Right. So based on that, the network layer will manage the things. Right. One more is data link layer. Packets raw bits from the physical layer into frames, logical structure, packets or data. Provides reliable transmission of frames. It waits for an acknowledge from the receiving computer. Retransmits frames for which acknowledged not received. Packets raw bits from the physical layers into frames. Okay. So this data link layer is a physical layer. This data link layer is physical layer which converts the bits into frames, provides reliable transmission of frames. Okay. In data layer, the data would be converted into, again, the data would be the PDU is frames. Okay. The PDU is frames. It waits for the acknowledgement. From the receiver computer. When you send something, it will wait for the acknowledgement from receiver. If that is done, then only it will continue. If the receiver acknowledgement is not done, then it retransmits the data again. It retransmits the frames. It retransmits the frames. So the responsibility of data link layer to keep the network alive by in form of frames. Provide the reliable transmission of frames. Okay, it transfers the frames. So from physical layer, the data may come in bits. Then it will convert it to frames. Okay, from top to bottom, when it travels from top to bottom, from the session layer, the data will from the network layer. From the network layer, the data will come to data link layer in the form of frames. Okay, vice versa. From this one, it will come as a bits. Physical layer, data transmits bits from one computer to another computer. Regulates the transmission of the stream of bits over a physical medium. Defines how the cable is attached to the network adapter and what transmission technique is used to send a data over a cable. Deals with issues like the definitions of 0 and 1 and how many volts represents and how long a bit lasts, whether the channel is simplex or duplex, how many pins are connected and what are the functions of each pin. Transmit in a physical layer. In a physical layer, this layer would be, as application layer is very close to user, physical layer is very close to machine. Right. So from human to machine. Now it comes from human to machine. In application layer, it starts with human placing some request, then it goes down, crossing all the levels, then it comes to physical layer, which is close to machine. When I say which is close to machine, so this is the one interface which interact with this is the one layer which directly interacts with the machine. Right? This is the layer which directly interacts with the machine. When I say it is a layer which directly interacts with the machine, what is the language of machine? Is zeros and ones. Machine can understand only zeros and ones now. Right? Machine can understand only zeros and ones. Now what this physical layer will do? It will convert those into zeros and ones. Because it has to put the data to, it has to move the data or move the request to machine now to process that request in a machine, or to process that request in a destination one. So it only zeros, and it will understand only zeros and ones, right? There is nothing but a bit. So it will transmit stream of a bits over a physical medium. Okay. So the request, the data will convert into bits. It is a stream of a bits. When I say stream of bits, bunch of bits. Okay. Bunch of bits transmits over a physical medium. Over a physical medium in nothing but a wire. Okay. In a network, if you want to pass anything, it has to convert to zeros and ones. There is a thumb rule, or there is a blind statement, or the thumb rule I can say. In a network, if you want to transfer anything, any data, then it should be a zeros and ones. That's it. So it defines how cable is attached to a network adapter and what transmission technique is used to send a data over the cable. When physical layer is a layer which has to transmit a data in a cable, so the physical layer has to understand how this cable is designed, or how this cable is connected. Right? Physical layer should understand how this cable is connected, and how we can transmit the data. What is the transmission techniques? What would be the transmission techniques based on the connection of these physical layers? Okay, based on the connection of the physical layer, based on the connection of these cables, the physical layer decide what is the transmission techniques. Okay, the definition of zeros and ones, how we need to create zeros and ones, how many worlds represents, okay, and how long a bit lates. Okay, all this functionality, all these responsibilities, all these points need to check by physical layer. Okay, because it is very close to machine, and machine can understand only zeros and ones. That is the responsibility of the physical layer to convert those requests, the segments, the packets, whatever, to 0 and 1, and passes to the destination layer. Okay, so that is the responsibility of the physical layer. Internet protocol versus OSI. Okay, these are some internet protocol. So we talked about application, presentation, session, transmission. Okay, data link layer, network layer, physical layer, right? So application layer, explicit presence and session layer missing in the internet protocol. Data link layer, network layer redesigned. Okay, so TCP is one protocol, IP is one protocol, network interface is one thing. So if you see here, from network to data link, it is a network IP, network interfacing. Physical layer is purely hardware. Transport, TCP protocol, and these three is an application, nothing but a software. Service in an OSI model. Service in an OSI model, each layer provides services to layers above and consumes services provided by the layers below. Activity elements in a layer is called entities. Entities in a small layer in different machine called peer entities. So how the services are provided in a layer? How the services are provided in a layer? From the high to low, application will give input to the lower layer. Then after presentation layer takes the input from the application layer and it moves to the other layer, right? Session layer. And session layer take the input from presentation layer and gives the output to the transport layer. So on. So output of one layer would be input of the other layer. So that is how it will flow. That is how it will be transmits or service. Okay, consumes. So the output of one layer would be consumed by the other layer. Okay, active elements in a layer called entities. Okay, the active elements in a layer called entities. Entity is a small layer, different machine, called peer entities. Okay, in a different machine, the entity is called peer entities. Right, peer entities. Here is one machine, and one more machine over there, some distance, and these both are connected. So that is called peer, one to one. one-to-one map. So these are some protocols: access point, service provider, service user. So service provider will provide the service, service user will use the service. Okay, service provider, service users, right? PDU is nothing but is the data, is that segment, what it is decided here, right? Layer n provides service to a layer n plus 1. Okay, so layer the service provider and this is service receiver or user. So it might be one service provider might be n plus 1, n service provider might be n plus 1 service users. Okay, you can see the abbreviation protocol data unit. PDU is nothing but protocol data unit. SDU is nothing but service data unit. Protocol data unit, service data unit, right? Protocol data unit is nothing but packages or is a segment. So that is called as PDU. Connections. Layers can offer connections oriented or connectionless services. Connection oriented like telephone system. Connection like postal system. Each service has associate quality of service. Till now we understood how the data flows across all those layers. So that is in a network, right? That is a network. It might be connection or it might be connectionless, right? It might be connection or it might be connectionless. Layers can offer both connection oriented or connectionless services. This can be implemented in both connection oriented or in connectionless. In connection oriented is like a telephone system. When you say connection oriented, the example is a telephone system. Connectionless postal system. Each service has an associated with the quality of service. Example, reliable or unreliable. Reliable service never lose or corrupt data. Reliable service cost more. Typical application for reliable service is file transfer. Typical application not needed reliable service is voice traffic. Not all application needed connection. When we talk about the reliable and non-reliable, then what is the qualities of reliable? What do you mean by reliable actually? Right. Reliable service never lose or corrupt the data. There is no it never lose or corrupt. There is no loss of correction of data in reliable service. Reliable service cost more. As is providing more no loss or no corruption data, so definitely the cost would be very high. Typical application for reliable service is file transfer. File transfer is one of the example of reliable service. Typical not needed reliable service is voice transfer. So in voice transfer you no need a reliable service because it may not be a connection network. Not all application needed connections. Yes, all application may not be need connections, right? Some might be connection, some might be connectionless, right? So reliable service is nothing but the service which provides no loss or no corrupt data. For such services, the cost would be very high. One of the reliable service is file transfer service. One of the reliable service which is not needed, which the reliable service is not needed in is voice traffic. Not all application needed connections. So this is about the reliable. So this is about the reliable. So far what we learn when we place a request or when two systems will communicate, what happens in the network, how the data flows from one system to another system. Okay, so really data flows as we expect, because application will take our request. It's an English terminology. Whereas in other end, the English message or the English scripted message has to convert to machine understandable language. Machine understandable language. Just please note here, machine understandable language. When I say machine understandable language, so machine can understand only 0 and 1, zeros and ones. So to convert those English few words or English sentence into machine understanding language. So what are these 7 layers will plays a major role. These 7 layers will plays a major role. Application layer is a layer which is very close to user, whereas physical layer is a layer which is very close to machine. From application layer to physical layer, the data will flow by changing its format. And presentation layer, the responsible of presentation layer to present the data to respective format, to present the data in its respective format. Same thing. So I send a request from A, it will went to application layer, it went to presentation layer, and so on, security layer, session layer, transport layer, network layer, data link layer, and physical layer. And response comes back again through all these layers again. When response comes back, then system will send a response. How it will send? 0 and 1. It will send to physical layer, and physical layer it will convert the 0 and 1 to frames, and it will send it to data link layer. Data link layer, it will pass the information to network layer, and in network layer again the addressing, the routing will be logical will be implemented. The responsibility of network layer to route those frames to a destination. It will determine what is the source, what is destination. Okay. Now we are moving from bottom to up. Okay. The receiver, in the receiver end, the machine will response back, comes into physical layer, go back data link layer, above network layer, then transport layer, then session layer, then presentation layer, then application layer, right? When it's come to application layer, it will be a beautiful page, or it will be a beautiful message which you can read. But really the initial format of data is that one. Say suppose I want to Google something. Okay, I want to display some picture. Okay, I want to search. I am searching some picture of some picture. Okay, some picture of animal. Say it will goes and it will go to data link layer. It will go to presentation, session, transmit, network, then data link, then physical, and it goes to the machine, and it will convert to 0 and 1. And machine says, it reads the 0s and 1s, it will understand, oh, this guy is asking for one animal pic. This guy is asking for animal pic. What it will do? It will do processing, and it will send again. How it will send? It will send 0 and 1. It won't send the picture. It will send 0s and 1s. Now physical layer take the 0s and 1s, and it will convert to frames, and it will send it to this one, data link layer, and it will do data link layer. It will club all those, and it will send it to network layer. Then now network layer will identify whose request is this. Is this request from A? Is this request from B, C, D? From where this request came in, it will determine. In network layer, it will determine from where this request came. So A sends a request. So okay, the network layer decides, okay, this request came from A, so I need to send the response to A. That identification, that determining is done in network layer. The network layer figure out, okay, A has sent some request, so this is response to A. At the same time, meanwhile, network layer will get more requests, some more requests, but it won't. But it's the job of network layer to send appropriate request to appropriate response to appropriate requester. Then A has sent picture. Some other will say song. Some other will say movie. So accordingly, it will transfer to the receiver. Then it will transfer to the session layer. Session layer transfer to presentation layer. When you go to presentation layer, then it will convert that complete data to as expected as a user. What will user will expect? user will expect a beautiful picture on a screen. Then presentation layer, it converts that data to a beautiful picture on a screen, and it will move to the application layer. In the application layer, you can see that picture got displayed. This whole story will happens in the backend. This is what happens in the backend. But this is in a very fraction of seconds, right? In a very fraction of seconds. You just really won't imagine these all things happen when I place a request in just fraction of seconds. So this is all about OSI models. So we learned 7 layers in an OSI model.